Hi everyone, welcome to this video on lesson 9 of the atomic structure and periodic table unit. This is the last lesson on atomic structure really before we get onto the periodic table and start to bring the two parts of this unit together. And I was going to start by just getting straight into the examples and showing how sodium ions form and then chlorine ions and so on. But then I realized it's starting very, very abstract, and actually a really important principle whenever we're teaching science is that we make sure we're building on students' prior conceptions and that we're always certain that actually they know what we're talking about when we're drawing these funny little diagrams with circles and dots and so on. So a good place to start, and the first two examples we've got here are sodium and chlorine, and it's a really obvious compound, and there's lots of reasons why that's a good one to start with, not least because it's really common, and students will have salt on their food every day. So what we can do is just start with something really, really concrete and actually show them this. And if you want, you could do all sorts of things and make brine, make a salt solution, and maybe even try and conduct electricity through it or whatever. But what you can then draw under the visualizer or on the board or whatever is, okay, if this is a pile of salt, if just common sea salt that I would use in cooking or on my chips or whatever, if I were to zoom in on here, well, what would it look like? And again, what we want to do is start with where students are at. So you might want to ask students to do this themselves on whiteboards. And what I'm expecting you're going to see is that they're going to recognize, well, salt is a solid. The fact that salt is a powder might confuse a few students, but if you need to, you can remind them that it's a solid. And what they're going to tell you is that it looks something like this. And in a sense, they are correct. It's this is one of the models we would use to represent any solid, salt being one of them. And what you can do is then add this and say, well, look, actually we're gonna deepen this. So this is right so far, and if we want, we could sort of show this, the vibration, and they're in this fixed lattice. They can't move, but they kind of jiggle next to one another. We did lots of these diagrams back in year 7. This is something that will be familiar to them. And then you can say, well, actually, salt is a compound called sodium chloride. Again, that's probably not going to be new to many of them. So we can show that this is sodium chloride with some NAs and some CLs. And again, it's a nice example to use because you have a 1-to-1 ratio. It's not one of those complicated ones like lithium oxide or something. So I'm going to put NaCl, NaCl, and so on. So far, we're not telling them anything too radical, too far different to what's going on. But now we're gonna muddy the waters a bit, and we're gonna say, well, actually, in real sodium chloride, this is not quite what it looks like. Actually, what you get is something that looks like this. So, if you've taught this before, you will recognise that we're skirting dangerously close to the bonding unit of the GCSE, and this is an example of ionic bonding. We've got these strong electrostatic forces between the ions and so on. But remember what we're doing here, because we're with year 9 students, we're starting from where they're at and we're slowly building up the complexity. So we can say, actually, the way these stick together is that they have opposite charges. And what we're going to look at in this lesson is what are these particles, why do they have a charge, and how is this useful in terms of formation and breaking apart of compounds. So essentially what we're going to do in the first two examples is zoom in on 2 of these particles. So what we can do is kind of zoom in like this. Again, you may wish to lay this out differently, but this is just as an example. So firstly, we're going to look at this one, which is 2311 Na, sodium. So I'm going to leave that up here. And for sodium, so let's put that again up here just to remind ourselves. I'm going to do the PNE again. So this, I won't spend too long on this, but again, make sure when you're doing this with students that you model it fully each time, because it's getting them into that habit of thinking in a disciplinary way. So, okay, I'm going to go through this. Well, that's got 11 because the atomic number is 11. That's 11. These two come to 23, so that must be 12. What I'm interested in at the moment is what's going on with the electrons. So I'm going to draw this atom here like this, and I'm going to draw it over on this side. And this is just building on what they did last time. So you'll see again, we're not really doing anything new yet. In each lesson in this scheme, we just want to add one bit at a time. And again, I've just gone straight to the drawing all three energy levels because I know this. If you're doing it, use this as an opportunity to reinforce what you did last time. So what I'm showing, what I want to show in this example is, well, okay, this is a sodium atom. There's no overall charge because I've got 11 protons and 11 electrons. And I could even add here that this has the electron configuration 2, 8, 1, something like that. But what you can explain to them, and we're not going to, I mean, they may recognize this when we go through it, but we're not going to show how this electron on the outer shell ends up joining with chlorine. We're just going to say, well, what if, and I tend to like to do this in a red pen, what if that electron disappeared up here? I'll do it in black. That was lost somewhere. Well, what would we have then? So what I'm going to do is draw a little arrow like this. I'm going to say, okay, here's my nucleus. They may recognize already, and we're going to emphasize this later, the nucleus hasn't changed. Nothing happened to the nucleus here. And that's important in essentially lots and lots of chemistry. So then I'm going to draw my second shell like this, my second energy level. I'm going to add my electrons in these two. I'm going to say, well, hang on, we only had one in here. So actually, we don't need that third energy level because it's empty. If you want, you could draw the third energy level and just show that it's empty, but I'm not going to bother. I'm just going to say, we've got something different now. That's interesting. So firstly, well, okay, what we could do is we could label this with its electron configuration. So now the electron configuration is 2,8, or you might say 2,8,0. Okay, that's interesting. And then what I'm going to do with students is say, well, let's look at this new particle that's been formed, and let's do P and E again. And again, this is where they need to recognize that nothing happened to the nucleus. All you did was you lost an electron. Something happened to cause the electron to disappear. And again, they'll look at that in more detail when they get to A level and stuff and think about ionization energy and so on. But for now, we're just thinking, okay, the electron just went somewhere, whatever. Okay, so how many protons are there? Well, the nucleus didn't change, so there's still 11 protons, there's still 12 neutrons, still 23 in total. That's not changed. But what did change was the number of electrons. That is now 10. And then this is the most challenging bit of ions. But again, laying it out like this, I think, is quite helpful because they can see, okay, so how many protons have I got here? Well, I've got 11 protons. Oh, but now I've only got 10 electrons. And this is where, again, you're going to have to recap on some prior knowledge and think, okay, protons, they have a positive charge, electrons have a negative charge, and so on. What you want to elicit here, though, with your students, and I'm not saying this is easy, this is a really challenging topic, but what you want to elicit is the fact that, okay, now, because we've lost an electron, we've got one extra proton. That means overall, we have a positive charge. A positive charge. And then you can relate this very, very, very abstract picture to this marginally less abstract picture and say what that thing in sodium chloride is this. It is exactly the same as a sodium atom, but it's a sodium atom that lost an electron. Now, again, if you've ever taught this before, you will know students find it really hard to get their head around this idea that you lose something, you get a positive charge. And there's all sorts of metaphors and stuff you could use. You could say, I quite often talk about, it's like losing a detention, because when you get a detention, you get a negative behavior point on Bromcom. So if a teacher accidentally puts one off and then takes the detention off, if you lose that negative, it's like getting a positive. I've heard people talk about colds before. It's like giving someone a cold, you're giving them a negative, or if you shake off the cold, it's something positive. I mean, yeah, it's a really tricky one, and it will take time. And what I would say is, if not every student gets it, that's okay. you're going to do so many of these in year 10 when you do, or maybe even in year 9 when you do the bonding unit. We're not expecting every student to understand ions straight away. That would be impossible. But I guess the point is, if we just repeatedly model this very kind of rigorous disciplinary way of doing it from first principles, like I've tried to show here, then they will, over time, they will start to get their head around, okay, I can see what's going on. So I'll just do one more. If you've got the hang of this, you might not want to watch the rest of this video. Sorry, I'm going to go here and then here like this. But I might also show them chlorine. You might not want to do it side by side like this. I'm doing it just because it's zooming in on here. You may wish to spread it out a bit more, but let's say I'm going to do chlorine 35. And again, there's a chance to revisit some ideas around isotopes here too. So I'm going to say, okay, if we're drawing our chlorine 35, let's do P and E for that one. So I've got 17, 17, these two are 35, so that's 18. Okay, fine, so now I'm going to draw this. And again, I won't go through this in loads of detail for the sake of this video, but model this step by step, because that's what's going to help students build this understanding by seeing it modeled to them again and again and again. So I'm going to do the 288 rule. I'm going to get my 8 in this shell. I'm going to end up with 7 in the outer shell, like this. Now again, what we need them to notice here is that there's something different going on. And we're not talking about full outer shells yet. I mean, a lot of that will come later. Right now, we're just talking about, okay, well, I suppose we are talking about full outer shells and which is the easiest way to get it. But you can kind of just say, let's just imagine this one gained an extra electron. And again, the more observant students will notice, well, hang on, there's one over here that's available, and this one needs to gain one. Why don't they just come together? And you think, ah, there you go, ionic bonding. Not every student will get that, though. What we want to model, though, is to say, okay, if this one were to gain one, and I add that, I'm going to add that in here. In fact, I'll add it in here later. What we would have is the following. So I'm going to draw the same thing again. Here like that. I'm going to add my electrons as I've been drawing them before. And this time I've got an extra electron. And again, you can use metaphors, or you could just go through the process. It really is up to you, and actually you're going to have to probably do a bit of both. If I just move my visualizer down, let's go through this again. Key idea, nucleus hasn't changed. All we did was add an electron, so these two numbers are exactly the same. They still add to 35. Let's not confuse ions with isotopes. That's a big no-no. But what happened here was I added an electron, so this number is going to go from 17 to 18, like that. And again, various ways you could do this. You could model it and say, well, this is plus 17 and this is minus 18, so the total is minus 1. But elicit that idea that overall what this means is, once you've added an extra electron, this particle is going to have a negative charge. And I think the fact that we put it in square brackets and put a minus there, it makes it seem like it's just numbers and stuff like that. But again, what is really important here is that we refer this back and say, this particle that I've called Cl minus is just an atom with an extra electron. This one that I've called Na plus is just an atom that's lost an electron. So if you keep moving from the kind of less abstract to the more abstract and back again, and keep showing students that these are equivalent ways of talking about the same thing, that's going to give them the best chance of understanding it. So I think I'll leave it there because this video is already very long. There is one more example to do with beryllium, which obviously that's in group 2, so that, and we're not talking about groups yet with the students, but that's in group 2, so that involves losing 2 electrons. You could also do further examples. You could do oxygen if you wanted, and maybe get them to do it on whiteboards, or you do it in the visualizer. You could do aluminium if you're really ambitious, because that loses 3. But what we're going to do is model as many as we need to, get students to practice, see how they're going, and then we're going to give them some deliberate practice, and I think there's 7 or 8 examples in towards the end of the lesson for them to have a go at. Like I say, don't worry if they don't all get it straight away. This is something that we're going to build throughout the rest of their time at school.